Hey guys, this is Srini and you're watching basic Python tutorial videos on my channel Python for Microscopists on YouTube. And I repeat this in every video. These tutorials are for beginners. You may be students, researchers, or anyone who is interested in image processing in general. In this tutorial today, I'm going to talk about classes. And to be frank with you, this may be a controversial statement to say classes probably is not necessary for you right away. I mean, if you want to be a software developer, and if in fact, if you want to manage your software, your code in a much better way, in a modular way, classes can be extremely useful. But if you don't understand this right away, this is no reason not to do Python, not to do image processing. In this case, classes allow you to logically group the functions and data. So it's a great way of actually managing your code and writing the code in general. But without classes, you can write your image processing algorithms. You can actually, even the advanced ones. So in general, the classes, think of this as a blueprint for what you want to do. Yeah, classes can have a whole bunch of functions. If you remember in the previous one of the previous tutorials, we talked about functions, where you define a whole bunch of code within a function, and then you call the function, it does a specific job. In a class, you can have multiple such functions. Okay, if nothing, think of class as having a lot of functions. And by the way, functions in classes are called methods. And the parameters that go into these functions, we call them attributes. Okay, and eventually another term that I want to throw out there is if you let's say call a method to perform something, these are it creates specific instances, and I'll talk about that in a minute. So this is the terminology, like a method, attributes, and instances are the three terms that you would hear when people talk about classes. So a good example, I guess we can think of is, let's say you perform, I think I have an image of a bunch of cells. This is again, I've used OpenCV, library to detect individual cells in this specific image. Now, what do you want to do once you detect a cell? Let's say you want to do some sort of a morphological measurements, and all of that. That all can be done again without the use of classes. I want to use this example to explain classes in maybe like 5 to 10 minutes or something. So now let's take this and say, okay, I want to name each cell, saying, I don't know, cell 1, cell 2, cell 3 or something. And then for each of this, I want to give X and Y coordinate, or I want to extract X and Y coordinate, but then I want to do some sort of a math. Let's say how far the one cell is from cell other cell. What is cell 1 to cell 2 distance or something. So for that, you can write like functions, but let's actually put everything in class and see if classes make sense to you. There are numerous videos on YouTube that talk about classes. So once you get some understanding, go ahead and learn more about it. Again, all of this after you master the basics. Okay. So this is not an urgent topic, but this can be a very useful and important topic once you cover the basics. So let's get back to our Spider, excuse me, Spider IDE. And first of all, to define a class, you just do class, let's say cell, okay? Yeah, so this is our class. I just labeled, this is exactly like how you would define a function, right? For function, we say def and space and whatever that function name is. So, and what is this saying here? It's the IDE is telling me unexpected end of file while parsing. What does that mean? If you don't have anything, in your class, then then it's going to say, okay, it's not, it's going to come up with that error. Basically, I can just do pass while I'm talking. This is a way of closing my class. Okay, if I have nothing else in there, you can do the same even for functions, by the way. And why did I do this? I have nothing in my class cell. I just want to show you creating a couple of instances. Let's say this class has a whole bunch of functions in it. Okay, what does that mean? So if I have cell 1, Okay, and I'm gonna excuse me, call this class, and basically this is my instance one. Okay, so if I instance one, now I can have multiple instances. Cell2, well, let's use the same convention. Underscore 2 equals cell, and then this is my instance 2. What do I mean by instance 1 and instance 2? So in this case, cell 1 is a completely different instance. I'm thinking what is the best way. Cell 1 is object 1, cell 2 is object 2. And let's go ahead and print cell underscore 1, and let's also print cell underscore 2. And when I run this, you should see that the cell 1 is an object at whatever that location, cell 2 is an object at this location. So these are two different instances, even though they're calling the same class cell. Again, I don't blame you if you don't understand it the first time. I don't even pretend that I understand everything about classes. I just know enough to kind of use them. But the more you use them, the more sense it actually makes. And that's why I said if you want to be a software engineer, this is absolutely a must. This is what object-oriented programming is. And Python is an object-oriented program, and C++, you know, you may have heard object-oriented, Java object-oriented. So we are creating objects in this case, and this is what object-oriented basically means. Now, just to take this to the next level, so hopefully we understand the instances now, and we'll populate this later on, but and hopefully it makes more sense when we do that. Now, if you let's say if we want to assign whatever we just called cell underscore 1 dot let's say name, because we want to give a name to our cell. Cell name equals to, I don't know, you can call this cell underscore 1. So this is my cell 1 name. Okay, now let's also give cell 1 dot x. So what is the x coordinate of my cell? Okay, so you can say cell 1 is at 0, 0. Okay, x is 0, cell 1 dot y. So I'm just defining various parameters. I'm not even talking about classes now. So if you want to give each of this cell a position, maybe this is how you can do it. And let me go ahead and copy, and let's just do cell 2 dot name equals to cell 2 dot x is let's say it is at 10, cell 2 dot y is at I don't know, 5. So these are various positions, and now you can copy and do the same for cell 3, cell 4, cell 5. So the thing is, I hope it makes sense here, we have same attributes or same parameters that we are giving for different cells in this case. So what is an easier way rather than assigning cell 1 name here, cell 2, cell 3, and all of that? Okay, so let's look at that. That's exactly why we have classes. So let me go ahead and comment that part out so we can look at that later. And now I'm going to start class cell. Okay, let me just call the cell demo just in case if we uncomment that later on, which means this also becomes cell demo. Okay, we're not using the class anywhere. So let's create a new class called cell, and within this class we need to define, again, def is for defining a function. Okay, and in a class by default there is a function called init. Okay, it's think of this as initializing the class. Okay, so by default, let's go ahead and show how the function is defined: underscore init, and then within this you can have some arguments, and you see it says C help type self for accurate signature, initialize self. What that means is the initialize, the first argument is automatically set, and I believe you can call it anything, but by convention we call it self. What that means is I just put self as the first one. Okay, just if you don't understand, again, initially just put self. Now in addition to self, what else do we have? We want to associate a name, we want to associate x and y. Okay, let's just call it x and y, and function, right? So we end with a colon again. So we initiated this function, and with the parameters self, name, x, and y. And self is something that you give, that you have to give as the first argument. And it can be called anything, but self, calling it self is the convention. Now, what do we want to initialize within this? Let's say self dot name. Okay, I'm just calling it name. So this can be anything. This can be self dot cell name. So my cell name equals to name, so which is that one. Okay, but again, it's easy if we keep all the terminology the same. So self dot name equals to self. By the way, this is almost like saying cell1 dot name equals to cell1. Instead of saying cell1 dot name equals to cell1, cell2 dot name equals to cell2, and so on, I'm just saying self, and the self can be cell1 later when we define it. Okay, self dot name equals to name. Okay. And now you know what I'll be doing for the other two. Self dot x equals to x, if I type self correctly, and self dot y equals y. Okay, so again, this is almost like saying cell1 dot name equals name, cell1 dot x equals to 0, cell1, you know, whatever that values are. So now we can create instances. So let's say this is our class. That's it. Okay, let me get out of the class by going back to the main program right here, just a few backspaces, and now I can create instances. And hopefully this makes sense when we type a couple of instances. Let's call cell1 equal to what is our class name? Cell. Okay, and cell1. This is what I meant to do. Cell1 equals to cell, and the first argument is name. Yeah, I don't have to do self here. Okay, that's can be a bit confusing. So first I just need to give it a name. What do we want to call this? This is cell underscore, let's say ONE1. And the next one is, it's going to tell us what arguments do we give here. Okay, so the IDE, that's why IDE is very useful. That's why typing in Notepad doesn't make sense. Okay, so I have given the name. Next I need to give x and y. So let's just say x is 0, y is 0. Let's also do cell2 equal to cell, and let's call this cell underscore 2 and 10 and 5. So this is no different than what I've typed actually here. All these lines of code now is just single line for each cell. Okay, so this is exactly why classes can be very useful. And now let's go ahead and say, okay, we assigned this. If I actually run this, nothing happens. I'm not getting any result because I'm not printing anything. So let's go ahead and see how to use these. So now that I've created these instances, I have an instance for cell1, instance for cell2. So how do I use it? Let's go ahead and print, let's say cell underscore 1, and let's print dot name. Okay, let's print cell1 dot name, and now you can see it should print cell underscore 1. Okay, cell underscore 1. You can actually print cell1 dot name, you know, and cell underscore 1 dot x, for example, and go ahead and print cell1 0 0 and everything. So hopefully this gives you an idea now. Okay, so we have only one function, and you can define any number of functions within your class. In fact, that's how you typically use it. You define multiple functions, and then you run various instances to you know, that keeps your code very clean. Okay, you can do pretty much the same thing without using classes, but this is a very good way of handling the code. Now, just for the fun of it, let's actually define another function, and now let's try to find distance between two cells. Okay, which means we need to know what the first cell is and what the second cell is. So let's call this function cell underscore distance, and again, this is a function within our class, and again, self is always the first one, and the other input that I want for this function is, let's say, other cell. Okay, so we have cell 1 and what or cell 2 or cell 3, whatever it is. The first cell and what is the second cell. Okay, so when you get the coordinates of these two, then you can find out the distance between these two cells. So this is our function. Now what do we need? So we need to calculate distance, and distance is equal to it's x1 minus x2, the x coordinate of the first cell minus the x coordinate of the second cell squared, plus y coordinate of the first cell minus y coordinate of the second cell squared, and the whole thing under square root. Again, this is basic math between if you know the coordinates of first point and the second point, that is how you calculate the distance, right? So it should be square root of, by the way, square root function is only part of math. We'll import that later on. First, let's not get sidetracked. So I just want self dot x. Okay, so this is the x for the first cell. Okay, and let's actually minus. Now I want the other cell, other underscore cell dot x. Okay, this is the x coordinate for the other cell. I want to square this, plus same thing, self is nothing but if it is cell 1, self is cell 1. If it is cell 2 that you are doing, it is second one is cell 2, and the other cell we'll call it. Okay, so you'll see once we do this. I just want to give an example so you can see how it is used in reality. So self dot y minus other cell dot y and squared. Okay, and I need one more bracket here. So x1 minus x2 whole squared plus y1 minus y2 whole squared, and the whole thing under square root. And it's saying that there is no SQ or square root. I mean, that's what it's saying. Invalid. Well, we'll get to invalid syntax in a minute, but SQRT doesn't exist. So from math, import SQRT. So this imports our function of square root right there. Okay. Now let's see what's going on with the syntax here. Distance. Let's see. Oh well, let's return the distance. Okay. Let me do this. Square root self dot x. Well, sorry about that, guys. I went through and then I had to make some correction there. So anyway, so this is basically nothing but distance equals to square root of self dot x minus other cell squared plus self dot y minus other cell dot y whole squared. Again, when you type, the syntax errors, they're not very clear, so you have to kind of take, in this case, it took like literally 30 seconds of staring at it, and then obviously something jumps out, and then you go ahead and fix that error. So anyway, sorry about that. Let's go ahead and continue. So now that we define this, now we have full advantage of the code reuse, right? I don't have to rewrite any of that. So all of the code now I can reuse for multiple cells. So let's define a few instances. So we already did cell 1 is whatever this, and let's actually copy this and paste it, and let's call cell 3, and cell 3 would be, okay, cell 3, and we can make this, I don't know, 20 and 9 or something. So these are the positions. These are this is how I define my cells, and now we just need to call our distance, right? I mean, this function is returning the distance between these two. So now I can just say let's actually do distance equal to cell underscore 1, right? This is the cell dot, I need to call this right here, cell underscore distance. Okay, so cell 1, and run this cell distance. Okay, and what argument does cell distance take? Self. Remember, when I'm calling it, I don't have to call self. What is my second cell? Okay, I need to tell what the second cell is. My second cell is cell underscore 2. Okay, so this is it. So my distance is equals to I may have made a similar distance is equals to cell1 underscore distance cell2. Let me go ahead and type, let's say our distance is going to be, again, let me copy and paste from my text, because I may have actually typed something wrong, and let's not worry about fixing it right now. So anyway, so my distance is equal to cell1. Okay, my first cell is cell1 dot cell distance, which is the distance function right there, and the argument that it takes is other cell. So my other cell is cell2. So in a way, I'm finding distance between cell1 and cell2, and I'm going to just print the cells are whatever units apart. So when I run this, you should see the cells are, well, 11 point whatever those many units apart. I can actually change this to cell 3, which would be distance between cell 1 and cell 3. It's as easy as that. So once we have all the code as part of a class, now we are just literally changing here. And once we have all the instances defined here, then, and by the way, these instances can be automatically defined when we detect these cells right there. So when we detect it, we know exactly what the positions of these cells are, and we can actually name them like cell 1, cell 2, cell 3. So all these instances can be coming directly from our previous code that actually did the object detection, or cell detection in this case. Once you have that, let's say you have another class right here that actually takes that and then calculates whatever you have in that code, in this case the distance between the cells. So I hope this lecture or this tutorial is not confusing. If so, that's fine. Go ahead and watch other videos on YouTube. There are so many of them that talk about classes, and classes are, again, a way, it's a blueprint of what you want to do with a whole bunch of functions, and it's very easy to call these functions even from outside this Python file. If I create a new Python file, I can always go back and call these classes, and the functions within the class from a different file. In fact, the way when you do from math import sqrt, it's in a way similar to what we are trying to do here. There is a class called math, and within that there are functions of sqrt. Think of it as pretty much like that. Okay, so anyway, let's move on, and in our next lecture start a new topic, and I hope you found this lecture useful. Thank you very much.